So this is notes 13, page 1, and probably a little bit of page 2. Our last topic is rational expressions. That's just a polynomial divided by a polynomial, something like x squared minus 1 divided by x squared plus 2x plus 3, say. That would be a rational expression. We've reduced rational expressions. I think that's a hando. That should be homework 6. On homework 6, you practiced multiplying and dividing fractions or rational expressions. And you should have noticed that multiplying and dividing fractions is not really any different than reducing fractions. We do need to remember that to divide fractions, we change the problem. We avoid dividing ever. We change it to multiplying by the reciprocal. And this really is analogous to changing subtraction to adding the opposite. And the other thing we have to remember is we never cancel terms when dividing or reducing. It's important that you specify when you don't cancel terms. When we're adding, we cancel terms all the time. Like negative 2x plus 2x, those are opposite terms, they cancel to 0. But when you're dividing or reducing, we cancel factors. And that's because like 1 times 2x over 1 times 2x, so the 2x's are identical factors, they cancel to 1 and you just get 1. So that's the huge thing with rational expressions. You cancel factors, not terms. So let's look at this next problem. Notice I'm still having you look at it. How many terms are there in this problem? Well, it's really just one term because this is division, and as long as you're dividing, you're just all in one big term, okay? And what's tricky is that within this big term there are terms, okay? So don't try to cancel the 1s, don't try to cancel this x squared with that x because that's a term, not a factor of the numerator. So we cannot cancel terms. We'll need factors. And there's basically 2 steps. You're going to need to factor all the numerators and denominators, and you're going to change to multiplying by the reciprocal. And you can really do both at the same time. So that's what I'm going to do. X squared minus 1. Well, you should be able to factor that one in your sleep now. That's x minus 1, x plus 1. This denominator here, I can't factor x plus 1. So remember, we just scoop that up in parentheses. See this times 1. Voila, it's a factor now. Now, don't let this throw you off. You don't see a denominator back here. So it's an understood 1. So when you flip it, the 1 goes in the numerator. And then I'm going to factor this, the GCF out. But as I flip it, I'm putting it in the denominator. Okay? So just took out the GCF. Now that I have everything factored, I can cancel identical factors, and I see a few sets, x plus 1, x plus 1, x minus 1, x minus 1, and I'm just left with 1 in the numerator over 2. This expression is the funkiest way of writing the number 1/2 ever. So this expression will equals 1/2. And it equals 1/2 for all values of x in the domain of the original, I'm running out of room there, expression. This is the original expression. No matter what you plug in here, as long as it's in the domain, you calculate it, you're going to get 1/2. So this is real tiny writing here. It's the same expression, but if you plug in 7 here and you calculate it, what are you going to get? 1/2. If you want to, go ahead and try it. If you plug in -23 for x, plug it in for x, do the calculations correctly, what are you going to get? 1/2. If you plug in 213s, heaven forbid that we actually go through that arithmetic, that would be nasty, but you know it's going to equal 1/2. However, what if you plug in -1? Well, if you plug in -1, you're going to get something over 0 right here. And it doesn't matter what you divide by, that's meaningless. Then if you plug in +1, you're going to have this fraction here, because that will give you 2 in the denominator. But if you put in +1, see 1 minus 1 is 0, you're going to have something times 1 over 0, which is undefined. So if you plug in -1 or 1, the expression has no meaning. And think about the word undefined. To define something means to tell someone what the meaning is. Well, undefined basically means no meaning. So as long as you don't plug in 1 or -1, then this expression will equal 1/2. So remember, we say 1 and -1 are the restrictions. So don't let x be 1 or -1. And if I asked you for the domain, you would say, well, you can use any real numbers but those, all reals, but x cannot be 1 or -1. Okay? I noticed when I was doing this, I forgot to fill in these blanks here. So this was the last step. We looked for identical, which is what we found, or opposite factors to cancel. So that's what I did when I was canceling those. All right, so let's try the next problem. Of course, I give you a harder one, but I'd like you to pause the video. You'll get more out of this if you pause the video, try to perform the multiplication and simplify. All right, so think about the steps you're going to need and go ahead and try it. I'm going to go ahead and go over this. This is multiplication of fractions. It's really the same as reducing fractions. I need to factor everything. I can only cancel identical or opposite factors, and I am not even going to think about canceling terms. That x cubed is a term, that x squared is a term, you can't cancel. All right? And don't get confused with something like this. X cubed over x squared. I can see where you might get confused as, oh, that's a term, that's a term. But see, you can write it as 1 times something, 1 times something. Now it's a factor because that's a factor of the entire numerator. You can cancel identical factors. That indeed would be x over 1. This x cubed is not a factor of the entire numerator. It's a term in the numerator. So what I need to do is factor. So there's a lot of factoring going on, and this is one of the types of problems where you need to be good at factoring. So you should recognize here, there's no GCF. That is the difference of 2 cubes. Identify the cube roots. The cube root of x cubed is x. The cube root of 8 is 2. And I'm just going to use the pattern. I'm going to follow the pattern to write the 2 factors using the cube roots. So because that's a minus, it's first x minus 2. So that's the short factor. Then the long factor is square the first cube root plus, because there's only one minus sign in the whole answer. Then multiply the two cube roots together, don't double it, plus square the 2. So that's how you factor that difference of 2 cubes. This denominator here, that is the difference of 2 squares. Be careful, since the 4 is in front, you need to write the 2's in front. So this is 2 minus x, 2 plus x. Okay. Then, looking at this numerator, there's no GCF, but I see that quadratic term, linear term, constant. Looks like it comes from FOIL. Open up my blank parentheses. Remember, this is in the numerator. I know it's 2x and x, and I know everything's positive. Write down as much as you know, because looking at that frames your thinking. So I know what goes here and here has to be multiplied by 6. Could be 6 and 1. I'm not really liking that. Could be 3 and 2. I cannot put a 2 here, because that would create a GCF that doesn't exist. But if I put the 2 here and the 3 here, outer is 4x, inner is 3x, yep, that's 7x. All right, then the last denominator, no GCF. It looks like it comes from FOIL, but this should look suspiciously possibly a pattern, because I see that 9's a perfect square, the square root is 3. 4x squared is a perfect square, the square root is 2x. Well, the middle term has to be just right. So 2x times 3 is 6x, double that, 12x, yep, that's it. So this factors as 2x plus 3 quantity squared. Now, when you're canceling, it actually can be a little less clutter if you just go ahead and write this as 2x plus 3 times 2x plus 3. It can just make the canceling look a little bit easier. So that's what I'm going to do. All right, now I'm ready to look for identical factors. I see 2x plus 3, 2x plus 3. Notice 2 plus x, x plus 2. Addition is commutative. These are identical, so they cancel. However, x minus 2, 2 minus x, subtraction is not. These are opposite factors. So they cancel, but they cancel to a factor of -1. So I look at what didn't cancel, what remains. I have a factor of -1 in the numerator times this x squared plus 2x plus 4 over 2x plus 3. And you can distribute the -1 in the numerator or not. I don't have space to do that, so I'm going to leave it. Sometimes I'm going to ask you for the restrictions. You should always be aware that when you're dealing with fractions, the denominator can't be 0, so there might be restrictions. I won't always ask you to list them. But remember, the restriction is on the original form of the expression. So I need to look at this denominator before I cancel. Now these two factors are easy. If x is 2, that'll be 0, so the denominator will be 0. If x is -2, this factor will be 0, so the whole denominator will be 0. So do not let x be plus or minus 2. Now, here, the 2x plus 3 is the same factor. So there's only one restriction here. If you can do this in your head, great. I kind of prefer that. But I know that I can't let 2x plus 3 be 0. So I can't let 2x be -3. So I shouldn't let x be -3/2. I just solve this not equal equation. So I add that to my list. Those are my restrictions. And keep in mind what this string of equals is telling you. As long as I do not plug in 2, -2 or 3/2, plug in any number for x, if I plug it in here, the original form, or if I plug it in here, I'm going to get the same answer. These two say the same thing for every value of x except those three. All right, so I thought I might get into page 2, but I think this video is long enough, so we'll stop this video here.